Ready, Ian? Good? Okay. Hi, I just wanted to briefly welcome everybody here. My name's Julie Smith-Galvin. I'm a town councilor here in Wakefield. And one of the best parts of my job is that I get to be the town council liaison to the Wakefield Municipal Gas and Light Department, which I really enjoy working with their management team and their commissioners and all the good work they're doing. So I'm just going to give a few opening remarks, mostly to thank the library for hosting us here. This is the second time they've hosted one of these workshops. We did a solar one probably about a year ago. It was very successful, so they've always had an open door policy with us, which I really appreciate it. And the Wakefield Cable Access Television, WCAT, is here. Because on a cold night, not everybody wants to come out, but we will be replaying this on WCAT and on their Facebook page as well. So I just want to recognize a few people in the audience as well. I think we have a lot of the light commissioners with us. So Tom Betcher is here, Jen Calais, there she is back, Ken Chase, and Phil Corsi. So most of the light commissioners are here as well, and they're a great resource as well for everybody. So I'm going to let Peter Dion, the general manager of the light department, give the introduction and take it away. So thank you so much.
Thank you, Julie, and thank you to the library also for hosting us tonight. The goal of tonight is really to share some information, and hopefully it's helpful to our customers. As Julie mentioned, we ran one of these in January about our new solar program, and for those of you who were there, I hope you enjoyed it and learned from it, and also to the townspeople. Right now, our solar program is doing very well. We're already 2/3 committed on solar projects, so there's still 1/3 of the incentives left available. So people that are considering solar, I know it's tough with snow on your roof right now, but the planning process does take a little time. So if you're interested in solar, you still want to reach out to us. All the information is on our website, and there is still rebate funds available for our solar program. Tonight we're here to talk about heat pumps and also some new incentives that we're going to be offering in that area as part of a larger rollout of new energy efficiency offerings from the light department. Tonight what we're going to start by is talk a little bit about the big picture of what heat pumps and energy efficiency are all about. And then after we talk about that, a customer of ours and a Wakefield resident, Kristen Weekly, is going to talk about the benefits that she's seen since she's installed a heat pump system. Ryan Williams, who's the general manager of 128 Plumbing, Heating, Cooling, Electric, is going to give us a little bit more nuts and bolts about heat pumps and heating and cooling systems. Dave Polson, our E&O manager, will then come kind of talk about the new energy efficiency offerings as a whole, including the offerings we're going to have on heat pumps. And then we'll have a panel discussion with any questions. So we'll try to, for the most part, hold our questions till the end. After the presentation, we'll try to keep it moving. But if there's something that's really vital, we'll try to answer it as quickly as we can. So to start, we're going to talk a little bit about energy efficiency as a whole. What is it? How do we benefit from it? At the global level, energy efficiency is how do we use energy more efficiently and more effectively? How do we use technology to help us use less of it? It's been a concept for the past 30 or 40 years, and really there's been a lot of incentive and drive in terms of technology and money that's tried to move forward. I think one of the things you'll see is that it is having an effect. Some of the big changes that have taken place in the past 20 years, LED lighting, for example, more efficient heating systems, cooling systems, all those things have a major impact. As a Wakefield resident, when I started here 14 years ago, our all-time system peak was 51 megawatts. So our peak in the summer of 2005 or 6 was approximately 51 megawatts. We haven't topped 47 in the past 7 years. So we've brought our peak consumption of energy down by about 4 or 5 megawatts through the efforts that we've had over the past 10 or 15 years. So in other words, people are using more efficient lighting and more efficient cooling, the big users of energy in their homes. And they've been doing that effectively, but there's a lot more that we can do to keep moving the ball forward. The value of the improvements that we make are seen for the next 20 years in terms of their operational life. You see LEDs now have 10-year useful lives. All the street lighting in Wakefield has been replaced with LED street lighting. That's providing a significant energy savings for the town. So those are some of the things that you can do and we can do as a whole to make the overall product better. Here in Massachusetts, and obviously we're in the middle of the winter now, heating is the biggest user of energy in our lives. In New England and Massachusetts, a little bit different than the rest of the country, obviously, because we're a colder part of the region. But we use roughly 60% of our energy keeping our homes warm. Cooling's a very small percentage. We also have our appliances and water heating. So if you look at the global energy dollar that we spend, gas, oil, electricity, and the energy that we use, a high percentage of it is in the heating side. So that's why we're here to talk a little bit more about more efficient heating through the use of heat pumps and the technologies that exist in that arena that have grown over the past several years especially, that make heat pumps much more viable in our region. They didn't used to be viewed as extremely viable for the Northeast where it gets colder, but the technology has grown and advanced so much that it really is a viable option in our region. So why are we investing more in energy efficiency? We're investing more because the more we invest in it, the less we have to buy and purchase, and it ultimately ends up saving us all dollars. We pay more to buy energy than we do to invest in energy efficiency, because energy efficiency measures that are intelligently invested in last for a number of years. Efficiency improves both comfort and reduces our bills. Better buildings and more efficient buildings have higher resale values, and they're also poorly insulated homes can be less healthy. One of the things that we're obviously finding, especially if we're in an older home right now, and we get a lot of calls on our gas side about over the past several days and weeks about heating systems not starting. Older equipment can be less reliable. Our gas service guys are out, starting up old furnaces, and so the newer, more reliable, and more efficient equipment improves our reliability as well. Ultimately, we're reducing the pollution of our environment by reducing the actual production of carbon, and we also reduce our needs for fuel from other locations, from overseas. So those are the main reasons why we pursue energy efficiency. It's much more valuable to us, and it's a better way to go. Why are we also upgrading the programs? Because last year, if you remember, we did a customer survey, and the survey said that was probably the one area that we could do more. Wakefield Gas and Light had very positive ratings across the board. We were in the upper 90s in terms of cost, efficiency, reliability. The one place that the customers said we could do more is on energy efficiency. So we took that to heart, and over the past several months, we've been working on developing new offerings and programs and improving our rebates so that we can focus and improve in that area. Ultimately, those investments help everybody reduce their costs by making smart investments in their homes that reduce their energy costs. We're trying to make the opportunities available to more and more people and make it more and more cost effective. We want to obviously incorporate new technologies into our portfolio. For example, we'll talk briefly tonight about Wi-Fi thermostats and the fact that those Nest and Echo thermostats that you can buy now. Ultimately, our goal this year will be rolling out a thermostat management program for customers that want to participate. If you want to participate in a load management program in the summer, you can get a small bill credit for allowing us to increase your temperature by a few degrees in the summer months at certain peak times. You'll be able to sign up for a program like that. So the technology will allow us to do more that ultimately saves a lot of people money and provides an incentive to you. And ultimately, again, the goal is to reduce carbon emissions as a whole. So with that, again, that's a high-level overview of why we're doing some of the things we're doing and why we're making greater offerings in energy efficiency. But I'd like to turn it over to one of our customers. Kristen Weekly is a homeowner in Wakefield, and she's already done a project like this that is very interesting because she's invested in it over several years, and she's made a lot of progress, and she can share with us why and how it worked out.
Hi, everybody. I'm Kristen, and I have a two-family on Spring Street that is the second unit, the owner's unit, is solely heated by heat pumps for both heat and AC. Sorry, I probably should. Oh. Sorry, forgot to do that. Awesome. So we have two systems that one's for the second floor, one's for the third floor. Our unit is 2 floors that we installed in 2016 and 2017. We did it for a few reasons. If I'm being completely honest, I didn't have a ton of input in the decision making. I just had a baby and was kind of checked out when this decision was made to install a heat pump. You know, basically the person that installed it had said that it was very efficient, so we just decided to kind of go with it. And it's definitely been a learning process. Sorry, went the wrong way. So we have the Fujitsu model numbers there. And we have ducted systems, so a lot of what you see in homes, I'm a local realtor as well, is you'll see like ductless mini splits, which people will put in for like AC as well as supplemental heat. We actually have ductwork throughout our house, so we don't have the mini splits on the walls. We have just ductwork that sends in both the heat and the AC into our unit. And when we first got this system installed, initially it was a little small for the size of our house, especially since our second floor is fairly open. So we actually had to get a bigger unit for the second floor. And then this last year, we actually got new blown-in insulation, air sealing, and insulation along the rim joists of our basement, which has really upped both our energy savings, but also increased how comfortable the heat pump is. Because when we first installed it, we had that on the second floor, we ended up having that really bad polar vortex a couple years ago. So I will say until we upped the size of the unit, it wasn't super comfortable initially. Once we got the appropriately sized unit, it's been very comfortable, and it's been way more comfortable since we got the insulation done and the air sealing done. We didn't realize, but we had blown-in insulation in our old house that had actually settled, and so our walls were half empty, half insulated, and so it was we were losing a lot of energy. So also, you know, the reason we did the insulation is to, make sure that I have a 4- and 5-year-old, that we weren't bothering our downstairs neighbors too much, and that, we live on Spring Street, which is pretty busy at times, so we just wanted to have a little bit more noise control in our unit. So we paid $14,000 for both systems. It was installed by Lynch Cooling and Heating, which is my brother-in-law. And so I talked a little bit already about the second floor unit not being sufficient. I think my takeaway from that is just make sure, it was kind of a newer thing for us and for my brother-in-law. So I would definitely recommend, getting an installer who is willing to work with you. I mean, he's wonderful and immediately fixed the issue when we had it. But getting a provider, which is what Ryan's going to talk about, that actually has educated us to heat pumps, what their capacity is, what they do well. So for our utility savings, Full disclosure, we do have solar panels, which we installed in October of 2017, so our bills are probably a little bit lower than what they would be without the solar. But we don't have a backup system. We only have the heat pump. We also, our electric bills include our car, because my husband has an electric car. So our bills over the last 6 months have been between $70 and $150. I will say that when we had the undersized system during the polar vortex, we had to use some space heaters that month, which is definitely by far the worst month we've had. It's been about $350. But last winter, the highest we had, I think, was about $200. And that includes the gas for our hot water heater, and the car, and then all of our heating. And in the summer, it usually ranges between $20 and $70 and we have air conditioning through the heat pump as well, which has been, I've never had a house with central air since I've lived in New England, and so that's been really, really nice. It's been an extra bonus. So, let's see. And before, I think our worst, because we used to have a steam heat system that was powered by gas, and prior to that, our worst bill, I think, was probably about $450 or $500 during a colder month in the winter. So now it's time for Ryan to talk a little bit about what to install and why. So.
Hi everybody, how you doing? All right, I've never used this thing before, so bear with me here. Perfect. First and foremost, appreciate the opportunity to be out here and the invitation from Wakefield Gas and Light. Also special thanks to our local Wakefield resident, Lindsay, who put together this beautiful PowerPoint presentation for us. So we're 128. We've been born and raised in Wakefield, and we've been here for 27 years. My father's a Greenwood resident and still remains, and so it's nice to be able to speak to Wakefield residents here today. What we're going to be talking about today is just a little bit more about the applications, what some things to consider, and what the versatility is that these heat pump systems can offer residents here in Wakefield. One thing I just wanted to highlight, you might see some collateral here, more based on Mitsubishi. We are a Mitsubishi Diamond Elite contractor, which basically means we install a certain amount of systems a year that allow us a certain level of credibility to offer more warranties back to our customers. There are certain credentials in order to do that, so you will see a little bit more of a focus on Mitsubishi. If you have more questions regarding different brands and makes and models, happy to answer those as well as I come. One thing I did want to point out, and just kudos to Wakefield Gas and Light, is that this past year Massachusetts was ranked 9th year in a row for the most energy efficient state in the country, and it's programs like this that are allowing that to happen. The statistics that you saw up there on the slides previously are really nice to see, and the focus there is clearly showing. So first and foremost, most questions kind of come into play is, what is a heat pump and can it actually heat my home? How does it work? And to really put it simply, is a heat pump system is an electric system. Okay, it's not using any fossil fuels. But how does it work? And to put it in layman's terms, it's basically moving heat from one place to another. So even in 0-degree days, there's still heat out there in the air, in the ambient air, and what a heat pump is doing is transferring that heat from the outdoor unit. Whoops, how does this work? Is there a little pointer on this? It transfers the heat from the outdoor unit, and it brings it back into the indoor unit. One of the reasons why the systems are so efficient is because it's not actually creating heat. It's not combusting. It's not burning anything. What it's really doing is just transferring the heat. And so That's why a lot of times for 1 unit of electricity, we're creating 4 units of heat in many applications. And that's why, as Kristen was explaining, she's seeing so much savings on her energy bills each and every year. So what you're looking at right here is a standard ductless mini split, where you have, 1 unit outdoors, and this is a standard conventional ductless mini split. And the reason they use the word ductless is because you can heat and or cool a space without any duct work. Now, in New England, this becomes very handy. We have a lot of older homes, a lot of homes that don't have conventional space to add ductwork, and so these are becoming increasingly popular. Kristen mentioned she sees them on open houses every weekend, and it's becoming also a value add also too to future home buyers and home sellers as a nice feature to the home. As we'll see here shortly, the neat part about this is that with a ductless system, there is no duct loss, right? So as conventional duct system moves air throughout the distribution system through small air gaps throughout the space, any duct system can often lose up to 30% of airflow, which is increasingly adding to the energy demand. So a ductless system doesn't allow that to happen because it's controlling just that singular space. And as we'll also see, it also allows a certain level of zoned comfort, which a conventional ducted system may not be able to provide. One of the things, if you are interested in these systems, that you're going to be wanting to be looking for is how these systems are rated. So I just wanted to show a brief description on a SEER rating and an HSPF rating. I believe in the program, if you are going to be taking advantage of some of these rebates, which Dave is going to be touching on later, there will be minimum requirements for that. So if you're interested in air source heat pumps, these are the ratings on how efficient the systems are. It's going to be a SEER rating and an HSPF rating. So what are some of the benefits of going ductless? In many cases, a lot of customers can see up to 40% savings, even over a window air conditioning system. Kristen had mentioned that some of the benefit is not only can you provide heat, but these systems also provide a cooling application as well, which show to be very, very efficient. You can heat and cool all year round. Removing window air conditioning units, those big bulky units, lugging them around in the summer is an added benefit, and not having to do that with a system like this. The systems are whisper quiet. They're not your standard blow as much air as possible type system. They're designed to move air low and slow and continue to move air throughout the day. Which with increased technology, like Pete had mentioned, those are some of the benefits of why we're able to maintain heat in a space for longer periods of time. We're utilizing less fossil fuels, so we're getting away from oil and gas, whether you're using it in a supplemental or as a primary application. We can now, like I had mentioned previously, we can zone a home. As you can see, I'm going to press the wrong button here. This representation is we have 70 degrees, I believe that's 78, 68, 74. You can have a room-to-room comfort depending on how certain systems are designed with this versatility. Earlier we mentioned no ductwork required in many of the system designs. Great for drafty homes, which we have here in New England, but make sure you take advantage of the weatherization rebate, which Dave's going to mention a little bit later. And another great benefit is for homes that have a conventional forced hot water system or a steam system, we're adding a level of indoor air quality with adding mini splits to your home. And there are great rebates, which Dave is going to get into a little bit later. So here's kind of the fun part. A lot of people are kind of ask about the design of the systems. What can you do? What can't you do? That's what we're going to get into here a little bit. So a standard heat pump, the way that they were introduced to the market approximately 10 to 15 years ago was that there was really only one option, and this was it. So I'm assuming that many people may already have these in their home, or they've seen them at a neighbor's house or a restaurant. These style indoor wall units are popular around the globe. We're just really starting to see them in New England over the past 10 years, but they're heavily utilized in Asia, South America, and Europe. as a really nice source to provide heating and cooling to homes. As technology has advanced over the years, new alternatives to design a home has increased. This has been an increasingly popular model right here, which is a ceiling cassette unit. This comes in multiple different models, but what you're seeing here is a unit that is recessed into the ceiling, so it's not something that is going to be installed on the wall. If you start looking around in more commercial applications, you'll see these quite a bit, and many homes do allow for this as an application as well. The nice part about it is that it is a singularly controlled unit, which you can zone from a room-to-room comfort. Also, if the nice benefit is that, let's just say somebody works from home, for example, and they have one of these units in their office, you can just heat or cool just that space and not the entire home, clearly making that compressor work a little bit less, using less energy. Another nice feature which a lot of people are unaware is this floor-mounted unit right here. Some applications don't allow for a wall or a ceiling. This is a really nice application that can fit in a lot of versatile spaces. And the increasingly more popular air handler. So heat pumps, when it comes to a ductless heat pump, conventional ductless heat pump, has really forever been known as those standard wall units. The technology has really advanced over the years. This system right here is utilizing a heat pump technology, but more through a conventional ducted system. So as we start having conversations about more whole house solutions, these are some of the design options that start to be coming to the kitchen table a little bit more frequently on how do I heat and cool my entire space, not just one room. So this system right here can heat or cool an entire home just off of that one standard air handler, which kind of looks and acts like more a conventional air conditioning system, but you're getting the benefit of utilizing the heat pump down to negative 13 degrees in the hyperheat application. I'll get back to the negative 13 degrees here in a second, because that's probably the biggest question most people are going to be having. Is this thing really going to work? Heat pumps never worked in New England. What has changed? This is where that technology really comes into play. So those are the four major design options. What we're seeing most people utilizing mini splits for or heat pumps for now are for three reasons. Like I had mentioned, a whole house solution. When they first came on the market, they were much used for a spot heating or cooling application. The systems have really advanced. We can, for systems like this one right here, if you see that larger condenser here, this was a home that we did that provided a whole home solution. So we can now deliver up to 4 tons of heating and cooling through an entire home, and we can design that accordingly. So our whole home application is becoming increasingly more popular. Our supplemental option, which is if you're trying to supplement your oil bill, supplement your gas bill, supplement your propane bill, a lot of customers are utilizing and designing systems accordingly that allow to do that. We also have a new product that's come on. I'll touch on that a little bit in a second, is an integrated control, and I will get into a little bit more detail on that. And when they first came on the market, individual rooms. So if we put an addition on a home, all right, my existing heating system is already at capacity. How do I heat or cool that space? I have a great room that gets quite warm. How do I condition that? That's what mini splits have traditionally done a really great job of on the market. So what I really wanted to highlight here with those several slides there is that there's extreme versatility in what heat pumps can do for your home today. So virtually anything that you would want done in your home, a heat pump can accomplish that. We can, like I said, a whole home, a spot cooling application, a supplemental application, with the versatility of all these products here with the air handler, the indoor unit, the slim duct unit, which Kristen has, the ceiling recessed unit here, the floor mounted unit, all working off of this one unit right here. And that's how that system would be designed. That one exterior unit can operate any option or variation all those units that we had just reviewed. Some of the additional benefits are there are some significant Wi-Fi controls that they've come out with over the years that allow you to function all these systems from your phone. We also have, like I'd shown before, all the systems are basically monitored from a remote, and each unit has an individual remote, and we can also do that from an MHK1 Wi-Fi thermostat as well. And then the integrated control. One thing that I just really wanted to highlight, this is a newer technology that hit the market this year, is that the integrated control allows this system to integrate to your primary heat source in your home. So there's a program out there that other surrounding towns are taking advantage of, which basically allows your heat pump to integrate to your boiler to supplement your oil or your propane. So you have a certain set point in your home, which might be 30 degrees, and your heat pump will work down to 30 degrees, and when you want your primary to turn on, it will do it automatically for you. So the technology, as you can see, is really advanced over the years, and like I had mentioned before, anything that you're looking to accomplish in your home when it comes to heating and or cooling, we now have one system on the market now that can do it for you. Just some additional things to consider, and Dave's going to mention this a little bit further. Kristen had already mentioned the impact of weatherization in the home. You know, buying and investing in a heating system or air conditioning system is one thing, but if the envelope of the home is not treated as well, we're essentially heating a home with open windows, right, all the time. So taking advantage of weatherization, proper insulation, proper air sealing is a really critical factor to making sure that the level of comfort that you're looking for in your home is accomplished. So, and that's no different with any heating system or cooling system. So make sure if this is an investment that you're looking for your own home, that you put just as much effort into the weatherization of the home as well. One of the reasons why the system is so efficient is just the way that the systems operate. Back in the day, heating or cooling systems only had one speed, right? You turn it on and it goes 100 miles an hour, right? If you had an 80,000 BTU furnace in your home, for example, you turn on the thermostat, and if it was going from 67 degrees to 68 degrees, that system would ramp up and distribute 80,000 BTUs no matter what, okay? The way that the systems are designed to work now is low and slow. So in all reality, these systems should really be operating all day long, continually conditioning the space, which allows that compressor to really stay slow and steady, not putting pedal to the metal all day long. So that's just something, just a quick tip just to consider. The days with newer technology, the days of set-back thermostats are kind of going away, which is kind of why the smart thermostats are really taking over. You're trying to not have that system work more than it needs to. The technology inside of new boilers, new furnaces, or heat pumps are actually doing the setback for you, if you will. In maintenance, you know, anytime you're investing in a heating or air conditioning system, maintenance is obviously critically important to continue to maintain that efficiency. So just wanted to have a general reminder on that. It's like oil change on your car, right? You just want to maintain that investment and make sure that it's operating at peak efficiency at all times. And just one thing that we just wanted to offer as a company from now until March 31st, if anyone has any questions on what is the right application for my home, what can I do, what can't I do, we're happy to offer just a complimentary evaluation. You can call in, no cost. Any questions that you may have about what you have existing. Is it new? Is it old? Is it efficient? Is it not? If I did go to heat pump, how could I design it? We're happy to answer any of those questions for you. You can call our number here, which is 245-9200. And thank you. Okay. One thing I wanted to add, we just don't have it on the slides here, but one of the introductions you're going to see into the program is for heat pump water heaters as well. Heat pump water heaters are using a very similar technology. and they're becoming increasingly popular over the years. But in an effort, once again, to reduce fossil fuels, and to have a more sustainable application for heating, but also for hot water, you are going to see a rebate in the program for a heat pump water heater. A heat pump water heater, once again, is utilizing electricity, okay, but it's using it considerably more efficiently. There was just some recent statistics that I did just pull. If you were to take an 80-gallon electric water heater, for example, the yearly operational cost of that would be approximately $419 a year. Taking that same 80-gallon water heater going to a heat pump, the operation cost was going to be dropping to $113 a year, which is about a $306 savings just on your water heater alone. So one thing to consider when investing in a heat pump water heater is just your free airspace. When a heat pump is used, like we had mentioned previously, it's moving air from one place to another. So it also needs air in that space to use. So a heat pump water heater is not truly designed to maybe be put in a closet per se, but it does need considerable space, approximately 700 cubic feet to continue to operate to pull that air from. But as I just mentioned, with the cost savings, it is still a really nice option, and the ones that we install both come with a 6 and or a 10-year warranty. Okay.
Thank you, Ryan. My name is David Polson, and I'll be talking about the incentive program. So I have the fun part. I can tell you how much money we'll give you. The new incentive program, we have it broken down into 4 different categories, and that's how we refer to them throughout the rest of the presentation. We have the appliance rebate program, which is basically all the appliances, and thermostats are included in the appliance section as well. And the maximum annual rebate for that category will be $500. Then we have the home efficiency program. The maximum amount in that category is $1,500 annually, and that has home insulation, air sealing, and if you wanted to upgrade your gas or oil system, heating system, $500 you could use towards that. We have maximum amount on that category of $1,500. Heating and cooling is really geared around the heat pumps. So the heat pump rebate is $1,000 annually for the heat pump, and we'll go over that in a little bit more detail. And then just as another part of the rebate program is that we'll have electric vehicle chargers available. We offer it free right now for 100% EV vehicles, chargers, and also we'll be offering some for hybrids. The rebate application will be available on our website by December 31st. So the program takes effect January 1st of 2020. And just as a reminder, again, I'll mention it a few more times, that part of the whole program is for the homeowner to understand where they need to invest their money. So the company pays, supports a firm to come out and do an audit of your home. And through that audit, they'll make recommendations, and you decide which pieces you want to use of that audit. But they'll tell you where the best payback will be. They'll recommend the systems. They'll talk to you about what you should think about. So except for the appliance rebate program, the home efficiency improvement program, and the heating and cooling system, you'll need to have a rebate done. Those are the most expensive ones, but they also have a big bang for the buck, so you want to make sure you invest your money wisely, and those require the home audit to be conducted. And the home audit, you do it before and then you do it afterwards to make sure everything's operating correctly, and then once that's done, then we'll issue a rebate. So here's our rebate incentive program in a little bit more detail. So you can see the appliances are all listed here. So we have a smart Wi-Fi enabled thermostat, programmable thermostat, which again is kind of moving away depending on what system you have. We offer the rebates, the amounts are here, and this is new, so this is up to 50%, up to $125 for a Wi-Fi enabled. We have a heat pump, a hot water heater. This is new, this will be $500 for a rebate. Air conditioners, standard air conditioner for a energy efficiency, Energy Star labeled air conditioner would be $50. Dehumidifiers washers, dishwashers, refrigerators are $50, provided you're purchasing more energy efficient appliances. Electric hot water, if you just go with a conventional electric hot water tank, with a rating here, you get $100 if you're upgrading. There's some limitations based on what's available, but there's $100. Washing machine, you get $50, again, provided they meet the Energy Star requirement. Just as a note, appliances must be new, limited to 2 thermostats per account, and just a recommendation on Pete talked about thermostats that can be controlled. So there's 2 right now that can be controlled remotely for load management, and we'll offer a program in 2020 around that. The Ecobee and the Honeywell manufacture thermostats that are controlled from a third party. Then the Home Efficiency Improvement Program, we have insulation, air sealing, and the Energy Star heating system. So the insulation would be home insulation, 50% up to $1,000, and air sealing, which is equally as important. If you're really going to insulate, you need to make sure you do air sealing as well. So the air sealing is 50% up to $1,000. So potentially, if you're doing your home and you're insulating, you really should be doing air sealing as well. You could get up to $2,000 in that. And now that would be the maximum rebate, but the maximum that we allow, is $1,500. So you could look at this and say, okay, is it $1,000 for insulation and $500 for air sealing, or you've done a lot of insulation and you want to go back to air sealing, is $1,000 for that. So you can juggle that around, and then if you're upgrading your heating system, there's $500 up to $500 available for a new heating system as well, for oil or gas. The heating and cooling, so the mini split that Ryan talked about, or the multiple zones ductless. So you can go with single unit, you can go with multiple zones, ducted or ductless, depending on the application. We would give a rebate on either one for 50% up to $1,000 rebate, and these are some of the energy ratings that you need: the SEER rating, the EER rating, and the heat rating is what some of these requirements would be. So you'll see the right here, it's 18 on the SEER, and then the other one is 9, which is a little, the industry minimum I think is 8.5 or 8.2. So we're looking for equipment that's a little bit more efficient than the industry standard. And this would be $1,000 annual maximum amount that we would provide for a rebate for this category. And then the EV charges, we give a free EV charger that you could install for up to $650 value, and then we'll give you a credit for hybrid charges as well as part of the program moving forward. So one thing to remember is when you do your home audit and you decide how you want to spend your money, as a homeowner, we would allow up to $2,500 a year for rebates. So you want to look at where you get the best bang for the buck, where you want to put your money, and then how much you can leverage with the rebates. And that's annual. So if you were to, Kristen put a system in, that maybe took more than 2 years. You could apply for the rebates in the first year when you do some work, and then if you add an addition or you do some other work and you want to add another unit in, you could apply for a second rebate the following year. So there's some flexibility based on what you're doing in construction or application on your house as well. Some of the questions, do I need to have an audit if I'm applying for an appliance rebate? The answer is no, you don't have to have an audit for an appliance rebate. You do need an audit, though, if you're doing the heat pump or the insulation. Can I install my own insulation and still receive a rebate? The answer is yes, but again, at the audit, it's driven by the audit. So you had to have an audit before you did the installation, then you went out and bought the material, and then you installed it. Then there'll be a post-audit to check to make sure that the insulation was installed and installed correctly. and then you'll be issued your rebate. And do I receive a check for the rebate, or is it, how's that done? So there's no rebates or incentives are applied as a credit. So rebates and incentives are applied to a credit towards your bill. So there's no check mailed to you. You get a credit on your bill for the rebate. And we will, as part of this process, to educate everybody, the closer we get to the beginning of the year, we'll publish some frequently asked questions. Even from tonight, we'll take some questions from everyone, and and we'll take some of those and put those in the frequently asked questions, so it'll be available for other folks. The audit and the rebate process is that the Home Efficiency Improvement Program and the heating and cooling rebates require pre and post audits. First step is to call and schedule an audit. So we use Muni Helps. So Muni Helps is we're part of an MWIC group, as part of the municipals. So there's 18 municipals at least that participate in MWIC and the Muni Helps program. So we're basically, our program is in line with what other municipals are doing. So the first thing you do is you call up and you schedule an audit. They'll come out and they'll do an audit of your home, and they'll make some recommendations. And then the energy efficiency audit will visit you. And then the customer can choose which improvements they'd like to make. So, they'll make the recommendations. They'll give you a copy of the report, and then you decide what you want to do. Once the improvements are complete, then you call up and you get another audit to make sure that everything was done correctly. So it helps you out as well. I mean, you're relying on a contractor to install, and I'm sure that they will do a great job, but it's another set of eyes to take a look at it, and it's helpful, and it's just part of the process, and then you'll be reimbursed, or you'll be given the rebate afterwards. So after the post-audit inspection has been completed, customer must submit the rebate application, provide original receipts and copies of energy audit. So you provide that to us at the Light Department, and then we'll issue your rebate. Then application rebates and EV charger incentives do not require an audit. So once you make those purchases, you just bring down the same information and provide it to us, and we'll issue the rebate. Rebates will be applied directly to the customer account, and the maximum total rebates and incentives are $2,500 annually per account. So some of the things that we will be making available to folks, we'll be posting some guidelines and process on our website. Rebate details that we went over tonight will be posted. Rebate application forms will be posted, list of frequently asked questions, contact information, and links to supporting and educational information. So those will be readily available to folks when, probably within the next couple weeks at the latest. And here's some reference material for some sites if you want to do a little research in the interim. There's some sites that you can go to. And that's it. I appreciate your time. Thank you. Now Pete's going to come up.
I'll just act as the moderator for questions for our panel. We did a good job. Thank you for listening, and then now we can open it up to questions. So we have our three experts. A couple things to clarify. First, the audits are free. It's free pre and post, so that's no cost. That's part of the service we've always provided. And we are working with our audit firm to educate them on our new incentives and make sure that they're more mindful of all the things we're offering now, so that they can be more aware as they're doing the audits what's going to be available to our customers, because we are taking some major steps forward. One of the things Dave talked about, the appliance rebates, some of those are the same, some of those are improved, some of those, and some things have been added to those. So it's important to look at each category, and these are all, they're not quite ready yet, so our board's meeting again tomorrow night. We've been working on this for several months. We want to pass everything by one more time with the board. And so some of the details, the fine details may change. That's why we haven't published anything yet. But for the most part, this is where we're going with it. And so I think as you have questions, we'll do the best we can to answer those. With that, do we have any questions?
Information on typical payback period for installing a heat pump versus like conventional
It can vary by size, but Ryan, what do you, what? They've asked me to repeat the question. So the question was about payback periods based on your investment in heat pumps.
So it's a tough question to answer, but because there are large variations of size of unit. So that's why we anticipate a lot of questions coming up regarding that. That's why we wanted to offer that just complimentary, just sit down, what would each home require? You know, I have one study, for example, one review off a 2,000 square foot home. The next home might be 3. The next home might be 1,000 square feet of conditioned space. So it's really depending on how many systems that we're adding to the home, the size of it, and the design of the system.
The heat pump decreases because you mentioned 13 degrees below zero or something like that. Does it get less efficient as it gets colder outside?
So the question was, is the heat pump less efficient as it gets colder?
So yes, and you know, the models that we install, there are two models. There's a standard heat pump, and then there's the hyper heat, both of which are designed at different ratings. But to directly answer your question, yes. All right, if a design temperature was at 5 degrees and the temperature dipped to 4 degrees, then yes, it would be using more electricity at that point to operate that system. But each piece of equipment is designed to a certain degree temperature.
Do we have one question?
I have a question. I have a home that's heated by oil and it's one zone, but we purchased the mini splits 2 years ago for central air, really. We've not used them for the heat aspect. I think I'm just gun shy to fire up the whole system and let it go 24/7 because of the cost. I mean, do you think that it would be more efficient to start using instead of using oil heat?
Directly answer that, yes. If that system was designed appropriately, and if it could heat all of the conditioned space that you're looking for,
yeah.
There is one. To kind of answer maybe both questions a little bit.
We have over 35,000 BTUs and 4 mini split units.
Okay.
In a house that's about 1,300 square feet.
So all I would say to that is that so in each application, right, to do a proper heat load on a house is the right way to design a system. Okay. And so if that were done, and let's just say all the design and installation practices were correct, then I would say I would absolutely go and test out that system. I absolutely would. And one thing just to consider in the heating months is oftentimes mini splits were designed for an air conditioning application first, heating second. Right now it's starting to shift a little bit. That outdoor unit, you want to make sure that outdoor unit is up off the ground. And if some of the pictures that we had showed we put our systems on an 18-inch stand to make sure that the system is up and out of the snow. It needs that free airspace to move. So if that is how it's designed and it's up out of the snow and it can operate effectively, I would absolutely go ahead and do that.
Can you run them 24/7?
Yes.
And still keep the costs, it still would be cheaper than the oil heat?
Correct. That's actually how you want the systems to operate. That you want the compressor and the outdoor unit, you want it going low and slow all day long. Coming home to a cold house and then expecting the heat pump to heat up your home in the matter of minutes it's not designed to do that.
Other questions?
Can those units be installed in an attic space?
The question was, can the units be installed in an attic space?
Some of the pictures that we showed earlier, the versatility in the systems do allow for the indoor units to be installed in that space. That air handler is designed to do that. Those recessed ceiling cassettes are designed to, the face of it is actually showing obviously in the conditioned space, but above that, you're most likely having that installed in an attic. Those ceiling cassettes probably are cresting about 30 inches inside that attic space with drainage and electrical and refrigeration, etc. So yes.
The unit that sets up outside always stays outside. That's not something that can be set up in.
Correct. What would happen there, again, you're moving that air, right? So if you had installed that inside of an attic, you would overheat that attic in a matter of moments. There'd be no more heat to pull out of that space for that system to actually operate correctly. Even underneath a deck, for example, there are certain limitations underneath the deck because you don't want to be enclosing that outdoor unit. Even some people want to put up lattice around the unit, etc. You want that thing to breathe and have as much space as possible.
Kristen, are you using yours for both heating and cooling? And were you originally, getting back to that prior question, did you always use it for heating and cooling?
Yeah, so we don't have another system at all. So it definitely works really well, but in some of the reading I've done about it, because I'm still learning about it, so this actually is probably really helpful for me too. We, with what Ryan said, like we don't adjust the temperature at all. It's at 70 degrees, and our bills are still really low. So
Yeah, and one of the comments I wanted in her presentation is that she's looking at her costs in total energy dollars, because she has solar panels on her roof and she's charging her electric vehicle. So she's factoring in electricity, oil and gas replacement, and gasoline replacement. So her total energy dollars are being looked at in a comprehensive unit. So even though her electric bill is at one level, that's also factoring her gasoline purchases and her heating and cooling purchases.
our car. So it's like $1,200, probably equivalent to all of our costs through the years. It would probably be about $1,200. Now, obviously, we have solar, but, so it's lower than it would be for like somebody who didn't have solar, but it's very low.
So as far as that goes, but my electric costs would go up, but it's just the oil.
The oil offset would probably go down. Yeah, the total energy dollar would probably go down.
So
As long as the system was sized properly.
So there's no cheaper way to heat a house. I mean, oil is one of the most expensive ways, but heat pump technology is one of the cheapest ways to heat a home. So you'll definitely, your bill might go up a small amount, your electric bill, but your oil bill will go down. I mean, if you do it properly, your oil bill will go down.
Just a little louder for that.
Your oil bill will go down dramatically, and your electric bill will go up some, but it's still cheaper to operate the mini split unit that you have than it is to go with oil.
So it's not like an electric, like it used to be, you shouldn't heat your house with electric, the costs are through the roof. It's not the same.
Yeah, it's not the same at all. It
Yeah.
uses a lot less electricity than that technology. So resistive baseboard heat is nice because you can just turn it on, but it's expensive to operate. So this is different technology. It runs on electricity, but really the technology is different, so it's much more efficient. There's truly no cheaper way to heat your house. So you should use it right now, and then you should see how you do. And then every once in a while, maybe start your burner up a little bit to heat it, just to keep it going. But try it and run it as much as you can. Play around with it a little bit, make sure you're comfortable with it.
Yeah.
But it definitely overall, your cost will go down.
Again, as Ryan said, assuming it was properly sized originally, and I don't know if you need to talk to your original installer to make sure you're coordinating it properly, and you probably still will need oil for supplemental at some points of the year, depending on how it was sized originally. But ultimately, the transfer of energy dollars will provide savings.
Thinking about electric baseboard heat and you're afraid to turn it on because that's what you're used to,
Yeah.
forget that. It's two totally different
Yeah, I think
systems.
that's what I
It
was
won't
thinking.
it won't double your electric bill. You might see a small incremental change.
Yeah.
It may not even be noticeable.
Well, just using the AC, we used it all summer, and our bill probably went up by $10.
Yeah, so,
And when I
yeah.
had the windows, it was $150.
Yeah, right.
So, I mean, I should use that as a.
It's the same.
Yeah.
Yeah,
Yeah.
that's
Yeah.
So I'm sitting on
to kind of go back a little bit to the savings in the sample that we use. Electric resistance is what you're referring to, Dave. There, the study on a 2,000 square foot house is showing over $2,900 savings from heat pump to electric resistance. And that same 2,000 square foot house, there's a $950 savings from oil to heat pump. And quite honestly, I think that's pretty conservative. and over propane was over $1,900. So whatever fossil fuel or electric resistance they're using, there is 100% going to be a savings utilizing a heat pump. Absolutely.
Additional questions?
Outside heat pumps, are they noisy?
It's a good question.
Just the question was, is it noisy? The unit, the portion of the unit that's outside, is it noisy?
It does make noise, but the technology has come a long way. The compressors are more efficient than ever, and they do make less noise than ever. As temperatures do drop and that compressor is working harder, you'll probably hear it a little bit differently, but we designed many applications right in backyard patios where customers are using them 365 and haven't had a complaint yet. The indoor units, for that matter, are extremely, extremely quiet. So the decibel levels, they say, and some of the marketing materials, lower than a baby's whisper. It moves air very quietly and very gently throughout the home. It's a different level of comfort than we're traditionally used to.
It's like a quiet fan outside. Like I was shoveling snow today. It's very, very quiet, even outside. But like inside, you don't hear it.
They just won't complain.
No.
Good question.
Definitely not. It's a lot quieter, I think, than your average AC units. Yeah. It's pretty quiet overall.
More questions?
So if I leave the house for a week or two, go on vacation middle of the winter, is there a temperature setback with this process?
The question was if you leave for a period of time. One of the things that was discussed in the presentation was try to maintain your temperature levels and not scale it back to 62 when you're out during the day and then try to heat it up to 70 when you get home, but try to keep more constant temperatures. So the question was, what if I go away for a week?
Yeah, sure. You can absolutely do that. There is obviously temperature control settings on each unit. So if you were away for a week, sure, you can set that back down to a lower set temperature for the week, but feel free to just maintain it at that level for that week. That does happen. These are great applications for vacation homes, so a lot of people do that, so you can absolutely do that.
But then it also doesn't really come up real quickly if you come back to the house. So
That would just
have it turned on the day before.
That's why the Wi-Fi technology really comes into play. That actually why it became such an increasingly popular push, is that yes, the systems, because they are more efficient, they're not designed to overly scorch a home in the matter of minutes. They are designed to increase temperature over a lengthier period of time, so yeah, that Wi-Fi capability does allow for that.
And the other advantage of the Wi-Fi is that if you're away for 2 weeks, you can actually monitor your house and you can check the temperature. You can see if the system's operating, so you'll know by using the Wi-Fi. So it's helpful that way as well.
True.
More questions?
Just kick it before you come home.
You can do that too.
Yeah, the Wi-Fi makes it cool. Any other questions?
Technology is still really changing a lot. I'm trying to get a sense of where are we in that curve? Is it almost better to wait a year or two until things kind of settle a little bit more, or is it time to jump in now?
It's a good question.
Yeah, so the question was, where are we on the technology growth curve? Ryan can speak from his side. From our side, we haven't improved our programs for a while, but we also don't like to jump into things on the bleeding edge of them. And the advancement in technology in the past 3 to 5 years has been significant enough that you can talk about year-round systems more credibly, and the technology around Wi-Fi is much more solid. And so a lot of the things that they're talking about today, these aren't bleeding edge technologies now. These are tried and true technologies over the past 3 to 5 years that are really making these units much more viable in the New England region, and the technology is much better, and especially in terms of the Wi-Fi enabled things that make it better controllable from other places.
Pete did a great job there, and I would absolutely agree. So we've been installing these systems for 15 years now. What I would say is that the tech, why it's becoming increasingly more popular now, is just the versatility of the design applications but the actual technology of the heat pump itself, can it actually operate in a northeast climate? No problem there. I would say that we've continually proven that year over year, and even the idea of maintaining a primary heat in your home, we're getting away from that now. 10 years ago, we'd said, hey, you know, keep that steam system in. Let's install these and let's see how it goes. If we're designing a system appropriately now, and we're designing it accordingly for airflow and for proper BTU, then the systems can absolutely perform. I would say the increasing technologies in regards to the Wi-Fi, yeah, those are always going to change, and there's always going to be updates there. But I would absolutely say the performance factor is absolutely there.
What's the service life of one of these units?
The question was, what's the service life of a new heat pump unit?
I think the yearly service.
No.
The life.
Like 15
expectancy.
years, or
Okay.
we've been installing these for 15 years.
Yeah,
when do they go kaput?
So the warranty on the compressor in and of itself is a 12-year warranty that we have there. Put it this way, we have not replaced any systems that we've installed. Since we're, like I mentioned before, since we're not combusting a fossil fuel, they're a lot. The wear and tear on the system is a lot less, and so we do anticipate these systems to be kind of running that 15+ year life cycle, absolutely. And in many cases, depending on compatibility, it might only be a replacement of just the outdoor unit, not the indoor, for example. So it wouldn't be a whole system tear out or anything.
So is the compressor that's outside, is that the part that's warranted for 12 years? And then how about the inner units? Are they?
I believe that they're everything on the indoor would fall under their 5-year part warranty, I believe. Yes.
Do they typically have less wear and tear, or more? I would assume the outside piece has more wear and tear.
Yeah, absolutely. On the indoor unit, all there is a very small evaporator coil and a blower. That's all that's happening. all the hard work's happening outside. It's just moving refrigerant through the coil and blowing across it. So it's actually, like I mentioned, a lot less wear and tear that way.
Be any type of annual maintenance one would expect with a heat pump?
The question was the annual maintenance.
Yeah, the annual maintenance depending on the design of the system. So it's an air system, right? And like I had mentioned before, there's a certain level of indoor air quality with all of these systems. So filter changing is going to be the #1 focus for any style of the system. So that evaporator coil, which is going to be transferring all that heat or all that AC, keeping that clean, is going to be #1 focus. So we do have yearly programs where we just go out, we clean, and they're a washable filter on many of those mini split indoor units. We take out the washable filter, we clean those off. That way we can ensure that the air that's passing through the system is moving freely. If systems do get clogged up over the years a little bit, we do have a more advanced system where we can get a little chemical in there and wash them out. But that might be after every 5 years, for example. After that, we're really checking refrigerant levels year over year, making sure that it's properly charged, and checking all the electrical connections and the drain as well. The systems condense just like any air conditioner in the summer months. So water is passing through as it's extracting humidity out of the indoor space. We just check those drains and make sure that they're draining freely as well.
Kristen, do you have an annual maintenance program on yours, or have you had any issues with yours since you've had them installed?
Any issues with ours? We definitely need to get ours serviced. We do change the filters regularly. We just have them sit tests every few months when we fun. So.
We employ that brother-in-law to come over and take care of it.
Yeah, I'm gonna try to get Ryan because it's more reliable.
Any other questions?
Wi-Fi piece of it, if you want to have that kind of thermostat installed, who does that? Do you guys do that? So if you already have a system, can you potentially tie it to the system?
Yeah, so the question was, can you use a third-party Wi-Fi system, or is that
who would install them?
Or who would install the Wi-Fi?
Yeah, so any The person who installed it should be able to handle that, but any HVAC contractor should be able to take a look at that. Dave and I had that discussion before the meeting today. Some systems were designed with that capability originally, some were not. So just double checking on the model of that and making sure it's compatible with either the manufacturer supplied Wi-Fi, or if you go third party, some modifications might need to be added for it to operate.
Okay.
But it in most applications it can be accomplished.
So you guys could come out and look at it?
Yes.
Okay.
Sure.
Do you know if the Mitsubishi ones are compatible?
The one that you have right now is most likely compatible with the image that I had up on the screen earlier.
Okay.
And if you want to look into it later, the program is called Kumo Cloud, and you can kind of look at the interface on your phone and what that capabilities are. Yep.
There's a question over here.
Department rebates going to be limited to air source heat pumps, or would they possibly apply to ground source heat pumps?
They will apply to both.
Okay.
The question was, will they apply only to air source, or would they apply to ground source as well? And they will apply to both. Question?
Just sort of look at it big picture in terms of sustainability and, you know, limiting carbon footprint. So it sounds like for the local application, there's basically no carbon footprint at all, right? So I'm talking with my hands. But so where does Wakefield get its electricity from? How much of that is sort of generated? Because obviously to run these things, you don't have to get the electricity from someplace.
So,
and so how's that electricity generated?
So our electricity portfolio is over 60% non-carbon emitting. If you count our nuclear portfolio, as well as our renewables around Berkshire Wind, Hancock Wind. So if you look at our entire energy portfolio, we're 60% non-carbon emitting. So that's kind of the starting point. And as we evolve over time, Berkshire 2 is coming online right now. So we gradually try to move forward on our non-carbon emitting footprint as well. So if you look at our portfolio today on our power supply, we're over 60% non-carbon emitting.
Also, if you have solar, you are immediately less carbon.
And then on top of that, you know, if you have a gas-fired boiler or oil-fired boiler, whatever that carbon output is stays the same. With electrification of a heat pump and electric vehicle, as the grid becomes more non-emitting, those devices by nature become more non-emitting as well.
Additional questions? Well, I want to thank you all for coming. Again, all the information tonight, as we finalize all the little last-minute details on it, will be available on our website. We took your emails. We'll be sending you out some email blasts as stuff becomes available. Don't hesitate to contact us at Wakefield Gas and Light, but feel free to talk to our vendors or ask questions. And we appreciate you coming tonight. Thank you, especially on the end of a stormy few days. So thanks.